Hello. Uh, can you hear me? Like, can anyone hear me? Whoever is there. So I will take some random. I'll take some random 2000 rated problems and then show what they are actually, because you might have never opened some 2000 problems. See, I have opened even 3000. I have typed already. Even 35 I have typed already. 34 I have typed already. 33 I haven't typed. Mm, you might not have even tried 2000 because you get scared, right? So I will just try to show you people um, by solving them by fuck, zero viewers. Yeah, anyway, I'll try to show you people how we can solve some, I mean, like what they are, like what those problems are. Like we have 5 pages it seems. So I'll try showing what those problems are, like what do they contain. I'll just solve some problems so you guys can get some idea of what they are. Okay. Oops, I forgot sharing screen while I was showing something. I was showing this. Here I was trying to say if I have ever typed 35 or 33 or 34 or sorry 34 or 30 or something like that when I was setting 2000, but then I forgot sharing the screen at that point. Okay, we have two viewers, so I will just continue. So far, what I have told is, you guys can hear me, right? Yeah. So far, what I have told is, I have just told that because you people get scared of 2000 rated or like even 3000 rated. I am not scared of 3002. I'm just trying to solve some problems and show you people like what the me solving them, right? Funful. Yeah. So I will be just solving some 2000 problems. I will try to go. I want some problems that I haven't read. I haven't read this probably. So like I'll just try to solve this one. Okay. Uh, it's not just about the solution. You guys can get to see how a pro coder like me a problem which you guys are scared of a bit, and I'm not scared of. So you can see how I solve, and you can know if it involves some weird segmentaries or if it involves some other things at all, because they never involve things at all because they are just problems. X and an integer k in one operation you can perform two actions. So we have an operation. We can choose an integer between 1 and k because we have a k and assign x equals to x times k. So you can multiply the current x with any number from 1 to k, or choose an integer, again choosing the same integer and assign x equals to x by a. So you can add some number to that product, or you can just remove that number to that product. It's like that it seems. You can add or remove that product. Find the minimum number of operations required to make x equal to y. Okay, here I'm unnecessarily using. In general, we never need not use any knowledge, but here I know such problem already. I think I'm not very sure, but we don't need any knowledge. So let's just try to solve the problem normally. So first we have an operation op. Um, xk operation is we can mm, make x times a or x by a if a divides x. We can do any of these things. Okay, where 1 less than or equals to a less than or equals to x, and we have to find minimum number of operations to make a number x equals to y, or determine if it is impossible. So we have two questions. Even if you guys can solve 2000, you get scared of thinking, looking at this and thinking maybe it involves some weird things or whatever. You can at least try for this, right? When it is possible and when it is impossible, you can at least try to think of that. If you try to see the next thing, it is guaranteed that sum of x and sum of y do not exceed 10 power 8. what, it's a very strict limit, 10 power 8. I have seen 10 power 6 so far, but I have never seen 10 power 8. But yeah, we have that as limit too. So if you guys cannot solve the whole problem, at least you can try to determine yes or no, right? Okay, when it is minus 1 and when it is not minus 1. So reading a problem and giving up on it or getting scared is useless. We can at least try for this. We can at least, when is it possible, impossible? This can be a question, right? Which means, see, uh, let's try to see, can we simplify the operation? Because an operation is given to us. Can we simplify that operation? Can be our first question, right? Because the operation says this, can we simplify the operation? If you see, if you see x in its prime factorization, why am I telling prime? Because uh, only when a divides x we are removing it, right? So if you see x as a number, big number of multiple primes, we are removing some primes together, or we are adding some primes to it, where the prime composes of the numbers between 1 and k. So this this is all about solving this problem, because as we can simplify this problem, because the thing is, we should not get scared at all, and this can be done in this problem, because we can simplify this problem. Because what's happening here is, if you see x as its prime factorization, some prime additional primes are getting added to x. Those primes should be between 1 and k. So see x in its prime factorization. If okay, 10 power 8 may mean root of x too. I mean, like we may be doing it in root x, or okay, let's leave that too. If you see x in its prime factorization, x and y out in, okay, let's leave that too. I'm just telling if you can simplify the operation a bit, like, because there are so many things from 1 to k, right? Mm, changing the operation to is not equals to L is not equals to k, where a is prime. This will not affect is it impossible or not question, because if a is less than k, all of its prime factors are also less than k. Instead of using a, we can use those prime factors to multiply. And if a divides x, all of its prime. So to answer operation to prime numbers a bit, right? Yeah, I will zoom it now. Uh, mm, mm, mm. Yeah, so at least we can try this. And even this is not that big of a thing. Like, can we simplify operation? Because now we can just look at prime numbers, right? And for x or y, k is less than or equals to 10 power 6. So if k is less than or equals to 10 power 6, this actually simplifies our problem. So this this thing doesn't change the operation much. So still, let's try to work on is it impossible or not question. Still, let's not care about minimum number of operations. If you still work on just if it is possible or not. Now again, because this is simplifying, the prime factorization is simplifying it. So x and y both have their prime factorization. So now it's clear. If you remove common primes from this thing, okay, or let's see like this, because now we can remove primes less than or remove primes less than k. It's like an equivalence relation. You can add or remove primes less than and then you see if two things can be equal or not. X can be made y, or y can be made x. So how to test it? Like both have their prime factorization. Mm, both have their prime factorization. So if we remove all primes less than or equals to k from both x and y, then if x equals to y, then it's possible, else it's impossible. That's it, right? Because you can add or remove primes from x which are less than or equals to k, and after you remove all such primes from both x and y, let's say if if the number if the numbers matches, then it's possible, otherwise it's impossible. I can solve if you think 2000s are a bit difficult problems. Trying to show yeah, as the title. So far what we have done is, there is no reason to get rid of any dating problem, because we can at least solve this problem, right? When it is possible, when it is impossible, because finally codes will be surely simple. And we can see here, we can simplify the operation, like we can restrict a to be prime, and that doesn't change the question of impossible or possible. It may change the number of operations, but it doesn't change the question of possible or impossible. So now this will also again mean, so now we have x and should make it y. We can at a time remove a less than or equals to k. See, a is a collection of primes, so instead of removing 1 prime, we can remove a collection of primes too, if that is better. So if that is better for us, we can remove a collection of primes too, or we can add some too. So let's see, x equals to some common and some p, uh, px, and y equals to some common plus py. Let's say these are the common things. Okay, I mean these common and px and py are complete co-primes, like they don't have anything matching between them, or like they don't have anything uh, matching between them. So now we have to remove all this px, and then we should add all these prime numbers of that are there in py, right? Both are two different questions, but it doesn't matter. Both are same questions, because removing some set of primes or adding some set of primes is the same thing. And px is just some product of primes which are like not there in this thing. So one question I have is, would c help? I'm unnecessarily complicating, I guess. Would c help in the sense, well, adding c doesn't help, but while dividing, would c help at all? I mean, when dividing, we can remove more things from C, right? But I don't think that helps, because when you're removing from C, it's unnecessary. You can remove smaller elements always. Smaller elements will also be less than K, right? So, so we need not worry about C probably. We can just keep it aside. What I mean is, C can be used while removing things, right? Maybe we can remove more things by using C, but it's already common, and these two are co-primes, where Px and Py are co-primes now. I mean, I'm telling co-primes and all, but it's all about, we have some are common, some things are not there, are there in this but not in this, and some things are there in this but not in this. So it's about removing this and to make this as this, remove this and add this. So it's not complicated. Like, it just means things are common. You have to make this as this. So remove what's not there and add what's there. So far it is that. So now, if this is true, that we need not worry about C and we can throw the C away, if this is true, then it's very easy to solve the problem. Not very easy, then the next step is clear. The next step is clear, that all we want is min operations for px. comma k. So we have an integer k. All we want is min operations of px comma k. Like how to make minimum number of operations from px comma k by removing any number from px comma k. Right. By removing primes. So we are already made a claim that, well, I think will it only involve divisions now? Because is it just dividing things or adding things? What I mean is, if it is just dividing things, see, because we already made an assumption that we can remove common things. So now, can we brute force this? Can we brute force this thing? Maybe we can brute force this thing of px comma k. Like this can be till 10 power 8. Ash, is OP. 2000 problems easily, but here go over the process or take time. If I can solve it, I'll go for another 2000 problems. But yeah, let me just think about it a bit. Minimum operations for px comma k would be everything needed now, and because then given this thing, and px has all primes less than or equals to k. This is also given for us, otherwise it's impossible. So now it has all primes less than or equals to k. So at max, we can remove each of the prime once, and it won't be too big because uh, x is less than or equals to 10 power 8. Maybe you can do root x. So let's just see some more time. So we have some set of primes in this px. All of them are less than or equals to k. And then we want minimum number of ways, because now we can remove some things together too, like which are less than or equals to k. And then again we have to add it. Like I think removing common elements is useless, because when we remove it you have to again add it at some other time. So removing common elements is useless. So now, because one thing we can think is, if you use common element, maybe you can remove some bunch of elements from px because you have used this. That's one logical thing, but you cannot use it and still you will have the same bunch of elements to remove from px. So we can remove common thing always as separate. So now we have primes px, right? And it's really difficult to solve on streams, but yeah, I mean, even if it's not that difficult, but if it's difficult, that makes me closer to your level. So see, if there is some prime z is not equals uh, greater than root k, we must remove it alone. No, this we cannot say, because we can remove it maybe with, I mean, we cannot remove two primes which are greater than root k. That we can say, because if we cannot remove two primes greater than root k together, because then the prime total will become greater than k. Let me try or think for some more time too, because now we just have to remove some primes, and we can remove them more at a time if they are all less than or equals to k. And what's the best way to remove them? But still, let's see how we can solve it. If I can, px has all primes less than or equals to k. Should I come back to this problem? Mm-mm. I mean, let's just keep some time. One small observation may solve the problem, right? So if you just keep some time, we group few things and then we remove them when they are less than or equals to k. We again group few things and then again we remove them. I think it should have something brute force, I guess, because I cannot solve some computationally complex problem, right? Because this problem is not that, probably not that easy. What I'm trying to think of right now, that when there are many primes and then trying to take a group which is less than or equals to k, I think the problem itself is a bit difficult, which I'm trying to see. Maybe if we can do some other brute force, that would work. So k and px can be a bit big. Px can be a bit big. Would sum of x work? I don't think we can maintain arrays of 10 power 8. Is it just complexity of O of x? You guys can try to think of the problem parallelly. Yeah, try to think of the problem parallelly with me too, because we have time, right? Like we can just try to think of the problem sometime. So less than or equals to k. See, the problem that I'm trying to think of, like when some primes are less than or equals to k, how can you group them so that and remove the best things? This is very likely it's a difficult problem, like, which means we need not actually solve that thing. We can do something else and probably solve the problem. We need not actually solve the difficult problem that we are trying to actually solve here. So let's just try to see it some more time. Where y is where y is 1. So yeah, one more question. Is it is it waste of time to think of this? This can be a question, right? Which is px comma k. If you have some primes multiplied, no, because you can have x equals to px and y equals to 1. So this is a problem that you must solve. You cannot escape, because when y equals to 1 and x equals to px, so thinking about this is not that much of a time waste. I don't mean you must think about this, but thinking about this is not much of a time waste, because if this is the case, then you must solve this, right? Is it is it I don't think greedily removing few things also will work, but because some things can perfectly match to k and then we can remove that thing. Some things may not perfectly match to k, then we cannot remove that thing. So did I read the problem correct? 10 power 8 may have, like, if you consider 2, it may have like, this is bad. I'm not able to solve these three problems now. Can I solve this thing? We are going over 2000 rated, so let's try to solve this. Hmm. Guys, yeah, that we can surely do. That we can do initially. That's what I removed the common numbers. Yeah, probably DP, because see, the problem that I am trying to think is definitely computationally hard. Like we probably cannot solve it. So it's definitely somehow brute force DP. Then find fastest way to reach one for both of them using DP. Yeah, that can surely be done. But I'm just saying if see, because the problem that I'm trying to solve right now is definitely I have never solved it on, that is surely not solvable. Like we cannot have a good way to remove them, because they It must be brute forced. Okay, so I'll just try to write that. See, this is GCD. This C is GCD, which is a common thing that we have, and these two are co-primes. So C is GCD. So I'm just telling now how to make PX to 1. If you know that, then again making PY to 1 to PY is same as making PY to 1, right? Okay, the fact that PX and PX has primes less than or equals to K. So we must do DP. So I'll just see. It's less than 1 is 6. I mean, okay, I can just write it with my experience that this must be DP because there's no good way to pay. Greedy will surely not work well. So, brute force. Another name for brute force is DP. So, we're going to brute force. Brute force in the sense we will try to cover all possibilities, and then we find them using all possibilities. We'll find the minimum number of operations to pick uh, things which are less than or equals to K, right? So now we have PX. Now we have PX. I don't think we can go over all PX's divisors because PX is less than or equals to 1E8. Some products of numbers. One few DPs we can write is trying to let's say answer of PX comma K we know. Uh, Maybe brute force on first operation. Let's say you remove D, so it will be 1 plus answer of Px by D comma K. This can be one operation where you brute force on D less than K. So you can make something like this thing where D divides Px. You can find all of these answers. But Px is 1E8, right? That's why I haven't wrote this. But it's surely some brute forcing because there are no nice problems to this. So let's still try to see some more time or just try to solve this. I mean, these problems are not that good problems because they are having brute forcing things, but greedy means is taking the max D the right thing to do in trying to find this answer is greedy because it's trying to take the maximum D. DP is worse. DP is trying to go over all possibilities and then try to find the maximum of that. So if we remove few things, I mean it must be DP, but why is PX can be very large, right? PX can be large, but all the primes in it are less. If I can solve it, it's worse. Just wait. Yeah, but that's what we have to find. We have to make PX fastest way to 1. Wait. Yeah, I think that seems nice. Okay, if you try to find this DP, if it has some pattern and all, answer. I'll just call answer of x. If x less than or equals to k, it's one surely, right? For all x less than or equals to k, it's one. And now if you look at two things, for all, wait, is it this simple? Ah, it cannot be this simple, right? If x less than or equals to k, it's one. Why did I complicate this? If x greater than k, it cannot be one because whatever we remove, it cannot be one. And wait, is it till x less than or equals to k square? Is it two? May not be when there is a prime that is greater than k. But if and given x has all primes less than k. So let's try to see this. It has all primes less than or equals to k, right? All primes are less than k. Now is it just two? Can we split x x? Can we try to maybe no, like this is another problem. Like if you try to remove the maximum possible thing that is less than or equals to k, will the other thing be greater than k? This may not be the solution, but still I'm just writing it. Should we go over another problem? No, I think I cannot make a video on that. All of my videos are failing these days unnecessarily. I think I should drink some water and think properly because it's an easy problem. So let's consider the set is equals to x times s equals to x times y, where 1 less than or equals to x less than or equals to k, and 1 less than or equals to x y less than or equal to k. This is it, right? Like, but then the problem will be too simple. I don't think it's this. Even if you leave that, is this the set that has is this set covers all all elements less than or equals to all elements less than or equals to k square, who has primes only less than or equals to k, but may not be, because if some prime, if you just consider some prime multiple times, adding one more of it will make this thing greater than k, the other thing will be less than k. Now this cannot be true because we can have few primes, let's say, okay, five primes, let's say. Mm, p into p less than or equals to k, but p greater than k, let's say. So, and p into p less than or equals to k square. If you have such a thing, we cannot always claim that both of them can be split into both less than or equals to k. So I think also this any good logic is also not there, I guess. So it's probably just brute force. I'm just trying to see if something like this may exist, but probably not, because we can have p square less than or equals to k, and this may also be less than or equals to k, because this p into p is less than or equals to k, and p into p can be greater than k. Something like this can surely exist, right? Because after that it became that. So this has no way to. I mean, I'm unnecessarily complicating this too. 2000 problem should have been simpler one, right? What could be the max size of that vector? Let me find out. Some vectors or factors of that. So if we can, but number of devices can be many. Like if you try to brute force on this d, number of devices can be many. Less than or equals to k. That is 10 power 6. I cannot ask for other problem now after coming till here. Hmm. This is obviously possible. It just means like log. I mean, p can be in that range where p square is less than or equals to k, but p cube greater than k, but p power 5 less than k. That's surely possible. K square. This must be brute force, but what can be brute force? Let's see constraints again a bit. We have to make X amount using coins less than or equals to K. With just the twist is coins are multiplying, we know all possible amount lie is going where the factors of the number. See, I think, see, it's definitely brute force because there is no good logic that the numbers will perfectly fit, right? Yeah, so it's definitely brute force. So maybe it is like some root X or root K type of brute force. If we can just use one logic or one point, I'll just remove all these things too. Maybe I'll go back. So we just want to find making X to 1, right? All primes in X are less than or equals to K. X less than or equals to 1 8, K less than or equals to 1 6. I think it's more about constraints. I don't know why I'm wasting time in other ways because I surely know if this is a problem, this can be solved simply. We must use some root X and root K. I know thinking like this will not work out. Like, think, see, our mistake is like trying to think more here. Like, we just have to find some fact and then try to probably apply these things, right? X cannot have two primes greater than root X, so most of its primes are less than root X. It can have multiple primes greater than root K though. So can we solve? Okay, can okay, for what, for what constraints? I mean, we must be able to solve smaller test cases also, right? So this brute force, for what values can we use this brute force? I don't like this problem, so I try some other thing to put 20 is 1 6, so X has at most 20 factors. Guys, to not ruin the stream, what I'm trying to think is go to some other problems and then come back here. Okay, is that fine? Can I get votes? Mm, yeah, so at least we can see solving some problems, right? Uh, what the fuck? This is not good. I don't like these things too. They're scary. Let me go and find one other problem. I actually don't like 2000 problems. They're all shitty problems. I would like to solve difficult problems. Mm, wait, 1011. Why is it 1011? Okay, recent problems are 1011 only, right? Yeah, yeah, recent ones are 1011. I thought something else. Mm, let me just read this because that would not, I mean, at least I hope this is a bit good problem instead of some brute force. An element bi in an array b1 b2 up to 1 bm has a local minimum if at least one of the following holds. b1 less than b2. Okay, it's assumed like 0 and m plus 1 are very big elements. So if we know local minimum is, similarly an element is local maximum if at least one of the following holds. Note that local minimum and maximum are not defined for arrays with only one element. Why? Okay, because it should at least be greater than the other thing, it seems. There is a hidden permutation. Okay, this is a good problem because there is a hidden permutation. Is it interactive? Not interactive, but okay, maybe. At least this is a good problem because there is a hidden permutation, it seems. Uh, the following two operations are applied to permutation P alternately, starting from operation 1 until there is one element left in P. Okay, remove all elements of P which are not local minima. So we remove everything which are not local minima, it seems, and remove all operations, or we can remove all the things which are not local maxima. Specifically, operation 1 is applied during every odd iteration, and operation 2 is applied during every even iteration. So if we first try to remove all everything that are not local minima, and then again try to remove everything that are not local maxima until there is only one element left in P. I can say the operation seems scary or a bit tricky because removing everything not local minima and then removing everything not local maxima uh, seems not that easy. But now, what do they mean? What do they mean? For each index I, let ai be the iteration number that pi is removed. Okay, we have iterations: odd iteration, even iteration, odd iteration, even iteration. They mean for each element there will be an iteration where it has been removed, right? So for the ith index, when it got removed is ai, it seems, or -1 if it was never removed. So finally, if it was never removed, it's -1. It can be proven that there will be only one element left in p after at most these many iterations. In other words, what they mean is, if we do such operations, the array will shrink very quickly, is what they are trying to say. Because uh, let's just try to take one example. If we remove all everything that's not local minima, most of them will be removed, right? Everything that's not local minimum means at least half of them will be removed, probably, because a local minimum has a local minimum. I'll just write that. If ai is local minimum, ai minus 1 and ai plus 1 are not, right? This is local minimum, both of them are not. So in the worst case, local minimums are less than or equals to n by 2, because we cannot have more than half of local minimums of n by 2, because even if we have this, both of them won't be. So in the best possible arrangement, we can at most have these many. So we remove at least greater than or equals to n by 2 things. If you are removing everything that's not a local minimum, we remove these many. So this makes sense that, okay, uh, we can do in these many operations. That makes sense. You're given an array. Your task is to construct any permutation of length that satisfies array A. So we are given an array. Our task is to construct a permutation that satisfies A. Is it impossible sometimes to satisfy that? It's guaranteed that. Okay. So here, first thing is we should not get scared of. Okay. So the problem is, let's say that we have operations keep going on. Operation 1, operation 2, operation 3, operation 4. And in each operation, we remove few elements. And the array A represents, whenever this index got removed, that number is array A. So we remove operations are fixed. Remove some which are not local minima, remove which are not local maxima, remove which are not local minima, which are not local maxima. The thing is, these operations look definitely complex. I give that these operations look complex, and I also give that. Mm, but because it's an easy problem, what we use, I mean, because solutions are simple too, what we use gonna be very simple. And 1 minute, it is these things. This is an important statement here. I mean, do you get what the problem statement is? So each index will be removed at some point, right? They are telling we have that array when each element would be removed. So this is important because uh, it could have been, wow, I never knew like this school A exists. Okay, this is important because also school B exists. This is important because they didn't say there exists an array, a permutation P under these constraints. See, this means whatever the array A is, you can get from P. That they are not telling. They are telling that there is one, at least one permutation for this array. So this means that using the array A, we can find some facts about P probably. Otherwise, so I mean, what's all given to us is for this array A there exists some P. Suppose by chance like there is only a unique P, that means we can find that P from this array A, right? And we also write some simple code finally. So uh, there is at least one permutation P for this A, means we can deduce some information of P using A. This is likely because that, even though the problem may look complicated, a bit complicated, I hate 2000 ones. If you see how many I have solved them, they will be less than 22 because I solved 2200 more because they were better problems, I guess. Mm, for this year, we can reduce some entry from this, I think. So all of them are less than or equals to log n, right? And a is minus 1 will be removed finally. Initially, everything that's not local minimum will be removed. So n must have, and you have people. The problem is a bit clear, right? We will remove few things from the first operation, right? So let's look at elements that got removed in first operation. Okay, if we look at elements that got removed in first operation, it doesn't matter what the elements. See, these indices got removed in the first operation, and if you look at the remaining things, and if you look at the remaining things, uh, because it's simple now, because if we can remove the ones and then solve the problem again, because that should not change the problem, right? because after you remove one, whatever the values left, they're all distinct. If they're all distinct, again you have to jumble them and then see if you can relatively make them go further, right? So what I mean is, let's say, uh, let's say you find some way in which you can make AI equals to 1 happen correctly. So, what I mean by this is, let's say you found a way, a permutation in which you can make 1 as not local minimum in the first operation. If you make such a thing, what the values in other places, it most likely doesn't matter, because after you fix that, you can jumble the other things, is what I was trying to use. But then they may disrupt the previous things being local minimum, right? See, I'm unnecessarily using more logic, so let's not go over this thing too. Wait, have I solved any difficult problems recently or not? Do we have the statics thing? No, I only have this thing. See, what I wanted to say was, if you remove elements that are at 1 and then look at the remaining things, I meant, like, because it's a permutation, we can again reorder them. So we can again solve them, is what I meant. But then if we reorder them, that may affect the local minimum condition that we already had, right? Uh, so let's leave that too. So now we have ones. We'll have too many ones. And when we have too many ones, that means wherever there is no one, wherever there is no one, that's a local minimum, right? Just so, I mean, I thought of using some big logic here, but that's also not needed, probably. I wanted to show that these things are simple, but then I'm using unnecessarily high logic and then making them seem harder. So let's just look at ones and non-ones. Okay. Hmm? Ones cannot be local minimums, and non-ones must be local minimums, right? So now, so now, can we, let's say, we have these as local minimums. So non-ones are the local minimums. One thing we can say is they are not adjacent. Non-ones are not adjacent because we cannot have two local minimums that are adjacent, right? That we can surely say. So in this week, if you can see, non-ones, they cannot be adjacent. That's one thing we can surely say. So we have few non-ones that are not adjacent, right? We can keep all the ones as, so if we do this, will it still hold? I mean, will there be something that will still hold? Making assumptions is easier, I guess, instead of trying to solve like this. Keep non-ones, smallest ones from 1 to k, and mm, can we show non-adjacent things? Can we surely form these things now? So all the non-adjacent things, let's say we kept 1, 2, 3 up to 7k. Now let's start from k, maximum value, reduce, and then again increase some values. Not even increase. The thing is, yeah, we can. We can probably. So, guys, the thing is, previously the thing I was trying to make, I was trying to see in general, if you stop, remove one elements, can we reorder this as much as possible? Is what I was trying to see. But then it may not be possible in a general case. But if we can keep smaller elements always in non-ones and bigger elements always in non-ones, then we can jumble them, because if bigger elements are above and smaller elements are below and then you're jumbling them, it will not affect the local minimum or local maximum thing, right? Because all of them are bigger than all of this, so it's again possible. So before, in general, I was trying to see if it's possible that removing non-ones is enough, because it's an easy problem, so we can remove non-ones. But then it's not directly possible to make such a logical claim, but now it's probably possible. So one question is, if there is such a thing, can we keep 1 to n in ones, 1 to k? Let's say these are the points where we have local minimums. Okay, we'll keep 1 2 up to so on k. This is possible. Keep 1 2 up to so on k at local minimum places. Now we have remaining elements. All the elements are greater than k. Now keep all of them as you like, and then just make all of them as decreasing. So it will be decreasing, and then it will be decreasing, and then it will be decreasing. So we have non-zero, non-one. Let's say non-one is O, and then again we have non-one, and then we have non-one, and then we have non-one, and then we have non-one. Let's say k is here. All these are less than k. All these are less than k. All of the other things are greater than k. How we can keep them is, we have some order, but we will just make these as uh, less than things. Like we can just make them as decreasing, and then we can again make these as decreasing. The remaining things that are greater than k, we can again make them as decreasing. So decreasing and then again decreasing, so that only this will be the local minimum, because this cannot be local minimum. All of them are decreasing. We kept them in any order, and then we'll just make in between everything. We'll just make decreasing, 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 and then maybe if finally few things are left, those we will just make increasing. So only question is, this means if there's a way to make ones disappear after first round, I mean, if there is a way in which the initial ones are consistent, then it's surely possible to remove the other things. Not even if there is a way. If they are not adjacent, that's enough. If they are not adjacent, if the non ones are not adjacent, that's enough to remove all the ones. Because if they are not adjacent, we can keep something higher than k here, and then all this will become local minimums. So all we want is non ones to be not adjacent, but it's actually given that there exists an p, there exists a p that will make sure that non-ones are adjacent. And the fact that all of this can be less than k and all of this can be greater than k now makes the problem, we can remove everything greater than k and we can order this as we like. Because even now if we order them as we like, that doesn't change the initial structure, right? They will still be local minimum. However you order them, they will still be local minimum, and you can solve the problem further. Previously, before making this claim, I was trying to see, can I order them? Then I told we cannot order them because that may affect the local minimum thing in the previous. But just using the fact that whenever non-ones are not adjacent, where is that? Whenever non-ones are not adjacent, we can go further. Just that fact has solved the problem. So now how we solve is we find non-ones, and then that's it. So now the problem is solved. We find non-ones, we find non-ones, we separate them, we find non-ones, and then we keep 1 2 up to 7k to there, and other things we just sort, like I have mentioned, decrease 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 and increase this, because if you decrease it, the loss may become local minimum. So decrease decrease and increase, and then we need not care about them, and the other things are less than or equals to half, right? So we solve the remaining problem on the other things. On the next things, we solve the remaining problem. So the problem is done. So if we just try to analyze what this problem uses, uh, they are asking us to find some p, but there is always this special p where we can keep local minimums, the smallest elements, and then you can go to the next level, because and solve. Now we should just solve the next level problem by removing the other things. We'll just solve the next level problem. So what this problem uses is, I'll try to write them down, because there is always a special array that simply allows us to solve the problem at higher level, operation by operation. So it's just, if you try sometime, we can figure out, like, okay, if we keep all the smaller things here, can we go to the next level? We can surely go. I was trying to make this going to higher level possibility even before thinking about anything. We can go to higher level if all O's are not adjacent, and this always holds true if uh, if it is a good array which came from some p. So if it has came from some permutation p, then this will hold at all levels, that non-ones will be non-adjacent. If you go to next level, still it will hold, and then again still it will hold. So now this is a bit implementation problem, but the fact that we can go to next levels makes it uh, an easy problem now. So I'll just try to make implementation for this. At least we have solved this. I got your ideas. I think, oh, like, let me read them. All numbers will be removed at last. One sort the minimum one, and one minimum one, and two will be the no. What I mean is, in the beginning, they will remove all the things which are not local minimum, right? So we can always set this non ones, which are like, which has not been removed in the first element. First option has 1 2k. If you keep them as smallest, we can make other things and we can remove them. And if you keep them as smallest, now we can again arrange them as we want, and it will not change the above structure that we made, because there is surely something here. There is a one here, there is a one here, there is a one here, there is a one in between those two. So if you rearrange them, this does not change what have happened previously. Do you get now, Aman, like what it is like? So this is the whole problem, that there is always a special array. I'll just keep it here. So this is the whole problem, that we can always keep the smaller things in the non-ones, and then again solve them further. Yeah. So to implement, first we have non-ones, and we have minimum or maximum, two things, right? When we proceed to the next level, now we have to keep twos will be local maximums, so we will keep twos as the biggest elements now, and keep ones as the and the rest as the smaller ones, and then we proceed till there is only one element which is -1. Then whatever the range is left, we'll keep that range as our thing. I'll come in a minute. I'll be back in 1 minute. So we can implement it simply. Yeah, maybe. Okay, at least Aman's that is true. Only Aman that you cannot say that. I get it. So you can see me implement at least. We will use same function. We have, see, when we go to next level, we went with the smaller elements. Now we may go with higher elements, because now we may use higher elements because we have local maximum. So at any level, we have a range elements L to R. See, this solution is surely simple, right? The solution is not that difficult now, because keep smallest elements here and then keep bigger elements in the aboves, and then there is a way you can make the local minimum work, and then you do the same thing repeatedly. So the solution is not that complicated. It just says there is always a way. The solution just says there is always a simpler way. See, the problem is looking complicated, but then you can always do such a thing. So it's all about just trying a bit. So we have a range of elements that has to be kept now, and we have a flag for local minimum or local maximum, and we have array A, and we should find array B using elements from L to R. We either remove last things, or I mean either the beginning few will go to the next level or the last few will go to the next level. So there is always a range. So is this fine? Like at any level, is this is what we do? Is that clear, Aman? Aman, like at any level. See, what am I again to show you guys is Implementations also will be simple all the time. Implementations also will be simple. So the problem is very clear now that all it does is, here I didn't write this for my convenience because I'm just trying to write it for you people to know what the problem is, like to judge the problem. Like they're telling, if there is a way to make, then always a special array, special permutation, which is just keep all the small things here, and then you can just keep the bigger things in some other way. And mm, and once you do that, the problem can be solved in a next higher level. You can only take the other things next. So, and then what I'm trying to prove again is, I'm just trying to use my principle. Solutions are simple. Yeah, we can just go further, that's it. So if we try to judge if how difficult this problem is, this is not too difficult, right? It looks a bit, but it's not. So now solution is simple, definitely. Proving is also simple. There is no proof here. It got proved instantly because the fact that these are too small will not affect the local minimum maximum structure. So we have a thing. And the proof is that if there exists, they will not be adjacent. And if they are not adjacent, we can always do this thing. So that in that way it's done. Now I will show that implementations also will be simple. Implementations also will be simple. At any level, it's there is a flag, local minimum or maximum, and we have a range of elements, and we have an array A, and then we have this, right? So I'll just do this now. Vector int fun, let's say. This is our range. This is our vector array A, and this is our flag local min. Okay, if A's size is 1, then that is most likely minus 1. That is likely minus 1. Mm, that's likely minus 1, and we can just return L, because at the final level, when there is only one element, we can also assert L equals to R if you like that. We need not, we can also do that. At that level, they will be, if it is local minimum or local maximum, doesn't matter. This will be the answer. I don't know if this syntax works, but so now if local min else, we can use two functions too, but why too complicated? If local min, initially it's local min, right? Uh, 0 means it is not filled. Okay, so we are trying to make this permutation P. So how I will implement is, our first step is filling. I will also make another array. Next level A, for your simplify. I mean, we will pass the next level A also, right, later. So we'll just make this another array. So for int I equals to 0, I less than n, I plus plus, if a of I equals to 1, not equals to 1. Okay, if a of I is not equals to 1, then what we do is we will fill it with smallest value. P of I equals to L, L plus plus. Right? This is what we should do. Filling all the rows with smaller elements. Filling all the rows with smaller elements. Now, let's fill the other things with decreasing values. We know that we just have to decreasing them, and then finally we have to increase them, right? So instead of decreasing, we can start with the maximum and then keep decreasing. But at final wo we should break, and then we have to increase for the remaining things. You guys get what I mean? So how will I do that is, uh, I will just decrease, and so let's just keep the final one that is not equals to minus one. So final will be break at equals to zero. At least one thing will exist which is not one, because there is something, right? I mean there is minus one, right? Break at equals to I. So here we have to just stop and then increase it again. So a of I equals to 1. P of I equals to R minus minus. If so there are two cases, right? If I less than break at, let's just keep this inside, okay? I mean, if you are before that, we can just keep P of I equals to R minus minus. Else we have crossed that thing. So now we can just increase P of I equals to L plus plus. So this seems fine, right? And this seems simple. So we're just doing 1, 2, 3 up to so on k. From R, decrease, and then just find this point and then again increase. Is that fine? Like the implementation seems fine, right? Just I'm gonna say yeah, so I can proceed. You there, right? Okay, anyone else can also say yeah. Mm-mm-mm. So this is a simpler one and then it's done. So now we have filled everything else. We have filled the array P, but we need not even fill the wrong elements right now. We can just fill them later, because they will be replaced, right? But let's fill them now too. We will again replace them later. I mean, these things we will adjust them again later, right? We will adjust these things again later. And let's also just make, now we want next level CA. Or should I have not done this thing? I think I won't do it now. I'll do it later. For nice implementation, I will do it later. No, but we have to do it now if I am fixing these things. If I'm using increasing order, I have to do it right now. I'm doing a bit complex implementation, but why decrease, and the last time I got your point, but then I'm going to subtract them minus one. I just thought I'll just subtract minus one from everything to keep it one. So we have next level, yeah. Why am I doing this? See, these things will again be replaced, so we don't worry about them. I mean, let's just find k instead, or else. I think I'll just find k here, okay? For simplicity. And so we are just getting the value k. And or we are reducing, but this is not correct. So this should have been, we just have to increase the other elements, right? So this should have just been L plus K. So this should have just been L plus K. See, I'm unnecessarily trying to use the same variables L and K. I'll use L temp because I don't want to alter the L because we are not keeping these things. I just don't want to alter that L. Should I reverse it instead? Should I just reverse them? I think that seems better, right? I'll just do R minus minus and then reverse them. This seems fine, right? Yeah. So this seems fine, right? Like, uh, sorry. So now we have our L and R clearly. So now we don't even need K now again. I just don't want to use it. So what we have done is we have reduced, and the final one we just flipped it so that it becomes increasing. So this seems simpler. So even implementations we can make simpler, right? So I just, instead of keeping random things, I started with the maximum. So I can go less, and then the last one I just flipped it. So this has been done. So now what we want is, we have L and R, we have local maximum, and we have A. We should find this A now. So to find that A, we can just do, or we can just do it here itself. I'll write it again. For int I equals to 0, I less than n, I plus plus. I mean, to not confuse, I'm writing them separately. If A of I is not equals to 1, this will go to the next level, right? Next level A dot push back of A of I minus 1. See, minus 1 will become minus 2. That doesn't concern us because we are only seeing 1 and not 1. So minus 1 will become minus 2 and we are fine with it. This is our next A. So all we have to do now is vector int p non-1 equals to fun of L comma R comma, because we haven't increased L, our L remains same and perfect. Next level A comma 0. Now it's local maximum. So now again, for int I equals to 0, I less than n, I plus plus, if we have phi not equals to 1, what we should do is, let's have a counter. P of I equals to P non 1 of, see, the permutation P non 1 will have whatever these things should be ordered as, and once we have that, We'll just keep that order into our non ones. So this is done. I mean, implementation is not that difficult, right? If you keep L to R, uh, if you keep L to R in some value, or if you should we write this again? I think we can write it again. It's not that bad. But now what we have to do is we have to keep L here, and then we have to increase L plus plus. And what we have to do here is again same. We have increased everything, but the last thing we will reverse. So it becomes reducing, and we have our local maximums and minimums perfectly placed. Is this the only thing that we need to change for that? And let's see how simple implementations can be. So is it done now? Then local min open. So we have to just flip it. See, I didn't even concern about K. I just thought, okay, for all the bigger things have been placed, we flip with this, the remaining things goes down. That's it. And this was just copy paste, just small copy paste. But this may not work. Why? Because it's written by me, and I don't seem to have good luck when it comes with this, when it comes to these streams. Mm-mm-mm. So it's a very simple problem. If you see how difficult is it to guess the structure, it's not that difficult, right? Local minimum, keep the smallest. That's the obvious thing anyone can do. Is it possible? Yeah, it's possible. Done. If it is smallest, you can alter them as you like. So go to next level. But what's the difficulty of this problem is where the difficulty of the problem is it looks scary. So if you see this in the contest when there is like 45 minutes left, this less than and this I minus ones will unnecessarily make us scary. Like, but if we just try for 10 minutes to see if something can be done at that, then we can just solve it. So do you guys see that? Like, it's a solvable problem. And if you think about implementation, you may think implementation is so scary in the contest, but how scary was this implementation? It's trivial. Keep these things. There are some O's. Reverse the other thing. So now this will give errors. So then don't laugh at me. Initially, it's local minimum, right? First thing that we have to take care of. See, this complexity I'm not caring because it's just log n levels. Log n levels should be fine, always. Every time it becomes half. If it doesn't give seg fault, we are good. So let's just try to look at this thing, if it is fine or not. 52413, right? First level, what all will be removed? Uh, first level, this is local minimum, this is local minimum. So 1x 1x1. So at second level we have just 2 and 1. Local maximum will be removed. So it's 1 2 1 minus 1 1. Is this the value above here? Right? Local minimum will be removed. So this will be minus 1. Not local minimum. Everything other than local maximum will be removed. So this seems working. And if you see how we are doing, wherever there are non-ones are, we are 3 1 2. What the fuck? Wherever there are non-ones are, we should keep bigger elements there, right? We should keep smaller elements there. Wherever ones are, we should keep bigger elements, which is 5 4. Was good again. So should we submit this? Third case is this, right? If you see 1 1 1 1, we have 8 7 6 5. So in the beginning, all of them will be removed. 4 will stay, 1 will stay, 3 will stay, 2 will stay. And if 4, I think it seems fine, it should be fine. So let's submitting. We are just submitting now. See, the difficulty of the problem is obvious. Like there's no difficulty. It has some implementation, but that also is very simple implementation. There are emojis. These are emojis. These are emojis. Wrong answer on test one. I think it's time for me to quit CP. I am not practicing from how many years? Here I am practicing. Here I am practicing. Here I am practicing, but I'm not practicing right. Maybe it's time for me to quit CP and do some better things like getting a girlfriend. I don't care how many. I mean, they're all hoes and man. I should not talk like this. Hmm? Guys, what's this? What have happened? Here we have answers. We're written in P, right? I mean, it worked here. Why doesn't it work there? $4,000 souls. That's too many souls. Why is it? Oh, answer is this. What the fuck? Okay, that's a different problem. Different problem, but same Do you guys see that? I mean, it's anyway wrong answer and test one. So what's the point in submitting here or here? We got the result we want, right? And it's worse now, 46 milliseconds. But wrong answer on test one is better than wrong answer on test two, at least. Test case 4. What the fuck do they mean? Initially, 7, 6, 5 will be removed, 2, 3, 4 will be removed. And then we are done. Guys, help me. Is this wrong? Initially, 7, 6, 5 will be removed. Wait, why 4, 3, 2 was not reversed? 4, 3, 3 should have been reversed, right? Guys, you should have told me this error that we made. Okay, reversing. We haven't worked this reversing well. Yeah, we haven't worked this reversing well. So we cannot reverse them all. We only have to reverse. Yeah, reversing should work. Yeah, we have to reverse P. Yeah, it works. I mean, we should reverse P, right? A has all ones. What's the point of reversing A? We wanted to reverse P. I'm right, right? So now it will be reversed. See, 7, 6, 5, 2, 3, 4 has increased. At least you guys will believe that I can solve 2000. 2000s are nothing, but at least if I can solve, the stream will not be that bad at least. I can be happy of solving such an easy problem, but during stream it seems like an achievement. So yeah, that's what it is. The fact that it is simple, we can believe that. And when we believe that, we will think a bit more to make the implementation simpler, right? Instead of writing in the sense, instead of thinking about this, if I have directly went and then tried instead of using some recursion or anything, if I've directly went and then see here in logic, I told we can keep any order and then we can make them this. But in implementation, I thought, okay, let's start with the biggest itself and then just do this. That was just imagining the problem as okay, if I start with the biggest itself, then it's easy to do this. And then reversing the last one seems easier. So if we believe that implementations can be simple, they can be as simple as what you can imagine. Make small, 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 just flip the last thing. Instead of flipping the last thing, I could have also done what is that point where I have to start from now. I haven't even done that. I just thought, okay, just this also can be done, right? So just I've just done that, and I haven't even found how many elements are there which are non-ones. I mean, this seems it needs more logic, but other questions can be simplified. So, and the copy paste was just L plus plus instead of R minus minus. I could have just kept L plus plus two, uh, but I thought for simplicity I just kept it like that. If I just so the thing is, so implementations are also simple. Will you guys be there if I try one more problem? Just one more, maybe one more solve, or is it too long already? You can be honest. Maybe it's too long already. I also have to sleep. We're having specific requests from someone. Croc Champ 2013 round one. Is it on CF? I wanted to try some 2020, 2400 or like that. I'll quickly I will quickly comment on the problem. Mhm. Should I go for one more 23? Who all are there? Hmm. I'll try to explain that, but I'll just finish the previous problem. Uh, if anyone is there, like from the previous problem, Aman, are you there? I'll just quote on this problem a bit more. See, Aman, if you think this one uses segment tree, you're definitely wrong, right? Yeah. Let's try to think about this thing. Like people may think, okay, 2000 problems will use. I have solved 3000 or about two, but 2000 problems. If you think, is there anything here which you could not have used on your own? No, right? Just guessing that, let's keep the smallest elements in local minimum. That's the first guess anyone can make if they try the problem. There is no other way, no other guess. If you just think, okay, I'll try to first with these things. Yeah, it's pretty doable. Everything is doable, but yeah, this is doable. So uh, we should be optimistic in the contest, right? So there is no reason, because if you can solve one 2000 problem, let's say by taking 2 hours, that itself would be very good for you in the contest, right? Like after solving A, B, let's just leave C, and then you have done this D slowly, and C also you might have done quickly. I mean, even if this could have been done quickly, because if it's a contest, instead of trying to do it systematically, we will very quickly verify the thing is, even before I fixed smallest elements here, I know that this likely uses the level thing, because otherwise it's complicated probably. So we can probably go 2 levels. So that seems doable or easy. Yeah, that's what I was trying to just say. See, CP contests or live streams will be long. People watch stupid live streams that go on forever. So this should be fine. So I'm trying to solve this problem again. 4000 solves is a lot easy. I want to do difficult ones too, but yeah, I'll just try to solve it quicker, I think. We often have to copy large volumes of information. Such operation can take up many computer resources. Therefore, see, after solving this problem, I will again a bit. quote on the previous one, so that we can see what we have done, or we can just learn something maybe and try to do it later. And if you see, the only error I made was this: implementation is so perfect that there were no other errors at all. And this too, we could have been careful. We have to find break point, so we found it. Everything else is so simple. Yeah. And this is one of the stupid implementations that I have made recently. I think not stupid implementations. This seemed like this implementation will be complex, and this itself we were able to make nicely. Then think about other problems where they just ask you to output n and m, where n equals to something into something and m equals to something into something, and just solving is the whole question. This at least has keeping values, taking from the previous level and then keeping values. Still, it was simple. We often have to copy large volumes of information. Such operation can take up many computer resources. Therefore, in this problem, you are advised to come up with a way to compute some part of a number array into another one. Copy. The telling computer resources will take, so we just have to copy some part of a number array to another one. It seems more formally. I will ask one more question. If you have to uh, keep the previous problem. Wait, is Lokesh there? I'm reading the problem for him, right? If you have to keep the previous problem into a topic, in what topic will you keep that? Will you keep it in graphs? Will you keep it in permutations? Will you keep it in where? Like, we cannot keep that problem at any topic, right? So topics doesn't make any sense at all at any problem. Let's see if the locus problem has some topic. It likely doesn't. More formally, you have got two arrays A1 and then B1. Also, you have got n queries of two types. Copy the subsegment of array A of length k starting from position X into array B starting from position Y. That is, execute for all Q. So they're telling length k, take from here and then paste it there. Both segments do not touch unexist elements. The given operation is correct. Both subsegments do not touch unexistent elements. So we take it from here and then go there. That means that doesn't go out is what they are telling. Determine the value of position. So we have two queries, kind of queries. Determine the value of position B. Find its value Bx. So only A gets copy pasted to B. So we have copy pastes, copy paste. K can vary. This may not be that good of a problem, but let's try to work on it a bit and then conclude if it is a good problem or not. We can keep chapters, right? So I'll just try to make a split. Like, I'll try to split the chapter. Maybe you can try the second chapter, or you can go over the first one too. I think second one is better because it has something. Hmm. It's fine if you can see it later, and if you can recommend to someone else, that's lot more than enough. So we take some part of k and then we keep it here. K is also variable. Xi and yi are variables, and at any instant we may be asked what's the value of this thing, right? So we can ask ourselves one question. Uh, Two arrays. Mm, See, my statements still hold for the previous problem too. So also for this, it will hold again. Segments of size ki from array A. I will try to see why I was not able to do this f. Where is that f? This one. We can ask one question. Will we do it offline or online? This can be a question. And if it is a shitty problem, it may use root and things, but I hope it doesn't. I hope it doesn't need us to do some brute force by using root and things. I hope it doesn't. I hope it's a nicer problem. So, when to answer what's BK? If we know who touched this last time, we are done. Do you agree to that, Loki? Because A is not changing. I don't know what do you mean. How to solve graph and trees question during the contest. See, NXT Durgesh. Is NXT coming from WWE NXT? There are no graph questions on tree questions. You can solve graph and tree questions during contest because you just get scared of them. Even 27, 28, or whatever the rating of the problem is, we'll just use DFS. It's not about graph question. It's about you not being able to read the problem at all. It's about you giving up before even trying the problem. And then you're asking how to solve graph and tree question. Like, what can I say? Even I do the same. Even I can't read the problem properly. Even I can't try with all of my confidence and all of my all the things I can do. I can also not do. So it's not about graph problem or tree problem. Yeah. See, graphs are easier because there are nothing we can do on graphs. All we can do on graphs is DFS or BFS. Trees at least may get more complex because trees we can solve something on subtree, and then maybe we use DP or something, and then we find for the bigger subtree. So trees at least has that. Graphs doesn't even has that. I don't like discuss somehow. I mean, I like it, uh, but I like more problems which are more nice, and all of them doesn't use anything much at all. Like the graph problems I have solved one graph problem in 126. That was nice one. I don't remember it now. Where was it? But this was a nice problem. Actually, I remember this problem too. If you see small code. All I have done was just DFS. This is actually a very good problem. And then some logic. And this is a I have done it when 2023 February, 2 years ago, I think, more than 2 years ago. Is this a graph problem? Is this a tree problem? It's a very nice problem. All you have to do here is find something and then it's done. Find some fact and then it's done. So is it a tree problem now at this level? Just DFS. Can't you find DFS and find how many things are there in the subtree? The thing is it even or odd is what it counts in this problem. So that's not a graph problem, and this is not what I wanted to show. Wanted to show some other problem, but this one is what I wanted to show. Nah, not this one. Sorry. Something like that. I think there is four things. Pairs of pairs. No, not this thing too. Yeah, this one. This is it. Here, they're asking us to either get a simple path of this size or do some valid pairing. We have to pair edges, it seems. And all we need is to look at the DFS tree for this problem. Just looking at the DFS tree. And then we can make either the pair or the path. Again, does this use any DFS topic? I mean, if you cannot do DFS for graphs and all, like we cannot say much, but if you see, it's all logic, it's all problem solving, it's all about to identify graph problem, because sometimes there was an array and we have to option to place and someone solved it, but hello Lokesh, are you here? So Durgesh, Lokesh, I'm asking Lokesh, not Durgesh. Yeah. So you guys should like the video because I'm okay. I don't know what you mean by bin packing or elevated rights, but do you agree to this statement, Lokesh? When we have to answer what's BK, if we know who touched this, have you ever got touched by someone? And if you get touched by someone, you should remember who touched you, right? To report them back. So if we know who touched this last time, because maybe that leaves a bigger mark. The previous touchers you would not remember, let's say. I mean, the last time who touched, they will affect you more, right? And if they are changing your value totally, then they will definitely touch you very well. Uh, I graduated 2 years ago, I think, 1 year ago. But Lokesh, do you get that? If we know this, if we know this, it's done, right? Do you agree to that or not? See, the problem is copy something from A, copy something from here, and then paste it onto here. And then we have to answer what is this value. So if we know for every BK who touched it last time, we are done. That's correct, right? Hello, Lokesh, you're there, right? Do you agree to this statement? I'm gonna touch you if you don't respond properly. Uh, Lily. Will be so now if you think solutions are simple, this seems to be the way to go further. It's very sure that we just have to find what was the operation 1 op1 are some part of a touches b, some part of b, not just slight touch, but it changes it whole. Damn. op2, not op, the query 2, query 1, query 2. If we know who touched this last time, get value of bk. So this you agree, right? Yeah, this you all agree that if we know this, we are done. So now, using whatever segment tree or something, maybe we can do that, because whenever operation 1 comes, you say this was the index I that has touched this last time, and then it's like a range update, right? You update that range, and then you know who touched this last time. When you are here, you know who touched it last time. So if you have an array and if you can do range updates, you can solve it. But why to use segment tree? Maybe can we do something better? We can use Fenwick tree too, because I like Fenwick tree because uh, as we go further, the indices that gonna keep touching will only increase, right? Do you get what I mean? Previously, one might have touched something, and then two might have touched something. After some time, only bigger things will touch, right? Only bigger things will touch. So uh, with segment tree, if we can do range updates, we are done. But I like Fenwick tree, so I will use Fenwick tree to get range updates and maximum. But I don't know if Fenwick tree allows range maximum, range update and point maximum. I know it does point update and prefix maximum. Sorry, maybe Fenwick tree cannot help. I know Fenwick tree helps for uh, prefix maximums. But let's just see if you can just solve it with trees or not. Not trees, sets or something smaller. Yeah, I think it can do point update and range maximum. If it is sum, it can do range update and point maximum. I mean, range update and point maximum too. But if it is sums, it can do both. I don't know if I can do the conversion for maximum too, because if it is just sums, when you have to, yeah, if it is sums, it can do. So now we have to find who touched this last time, right? Let's see if there is a way. Let's see if there is a way. Mm-mm-mm. See, but Fenwick tree, we can still probably use Fenwick tree. We can still probably use. So let's just see how we can just solve it. Like now we just have to maintain the who touched it last time. So to do that, I mean we can do segmentary. We can use segmentary too, but just let's think of some sets if they would work or not. Give me a moment. It's just range update to increasing values. See, why I am trying to think of some way rather than using segmentary or Finvectory is because I just don't want you to think unnecessarily something or like that. So, mm, can we maintain all the updates in a set? Let's say you have uh, all the updates in a set. Do you get what I mean? So the array, this segment has been touched by this, and then this segment has been touched by this, and then this segment has been touched by this, and then this segment. You have this in a set. Now a new segment came. When that new segment came, you just have to update this set again. So you will remove few things. But whatever you remove, you have added it only once, and you're removing it once. So that won't increase complexity. So you can just do this with sets too. If you prefer implementation, we can just try that. Like if you are bored, you can try that implementation. Like when you have a new segment, you find the first set element that will overlap with this, and then you shorten it, and then you shorten it, and then you find all the segments that are intersecting with it, and then you just remove them. and then you find the next segment here too that intersects with it. You just remove that and then replace it with whatever it is, and then you have this segment. Maybe you can keep this segment as a pair, L comma R comma, you can just keep it as L. You can just keep the starting element, right? So you can keep it as L comma, its value would be I or something. Do you get? Is that fine? I mean, all of our segments will cover the whole array. Let's assume. Let's assume initially all of them are 1 1 1 1 1, and finally all of them will cover a whole thing. So just keeping L is enough. And comma pair I, we will just keep what the value is, who touched it last time. So now when a new thing comes, all we have to do is from this L, when this L gets added, we need not worry about the previous thing too. It automatically got cut. If you add this inside the set, it automatically got cut. Do you see that? Okay, again. If that's the data structure you're maintaining, when you just add it, the previous thing has automatically got cut. But now you have to remove things. Yeah, okay. So the set we are maintaining, let's say these are our segments, okay? And our set S with values 2 1 0 5 with indices 0. Let's say this was 2 and this was 6. The beginning element is 6 and this was 10, 11 by all even numbers. So what I mean is, so our set has 0 2 6 11. So this 0 is associated with the 3. Let's keep that aside for now. What I mean is, when you add something at 4 like this, what I meant was, instantly when you add 4 into the set, the 2 automatically got cut, because 2 to 4 has automatically got cut is what I'm just telling you. Share your screen. Wait, can you see my screen? So what I mean is, when you add 2 to 4, when just after you add 4, this thing automatically got cut. You need not worry about removing this part, right? And you have to remove everything that is greater than this 4 but less than or equals to this next value. And then while you remove it, while you remove it, you will keep track of the last segment that you have removed. And if that last segment, fuck, what about now? I drew a lot. So let's say these are our segments. Okay. Our set has the starting elements 0, 2, 6, 11. Now let's say we have a new update from here to here, which has 4, which starts from 4. What I meant was, as soon as you add 4 to that, the previous thing got cut already, is what I meant. Is that clear now? And now, if something starts before this, we keep removing it, and then we keep track of the last one that was removed. Here, see, we add 4 to this. So 2 to 4 has already been cut. The two thing has already been cut. So 2 to 4 we know. And now from 4 to here when we add, we have to remove 6. We have to remove anything in between 2. We have to remove 6 totally. We have to remove 5 too. So what how we will do this is, yeah, I will implement it too. I'm just giving you, I'm just making it simpler for us. It's simple implementation. That's why I will implement it too. So I'm telling how to implement. So we remove this, we remove this as long as it is less than or equals to this, we remove that. And if it is less than or equals to that, what we will do is finally we will see where's the next one is. Okay. If the last one, if k not equals to, let this be L, let this be R plus 1, we add the last element, which is 5. See, we will add this remaining part as R plus 1, comma 5. So we will add R plus 1 here. If it is less than 11, we just add that with value 5 corresponding it to. Is that fine? Did you get it? I will also implement it. So you can see me implement it. See, uh, uh, see how segment tree is not needed here too. If someone really don't want to use something they don't like, they should be trying to understand how they can use binary search, like Unix says binary search, and just solve it using sets. Like I will do it now. See, uh, do you see how instead of maintaining segments, maintaining adjacent segment is helpful? Do you get that? I'm trying to maintain adjacent segments. Then I can only maintain the first element. People won't even try to use this much amount of small amount of logic, and then they want to learn segment tree. See, initially I will associate 0 to everything. Okay, initially I will just keep everything as 0, and then I'm adding all the elements. I will also add n comma 0 for simplicity. So initially there is 0 comma 0, 1 comma 0, all 1 1 1 1 individual segments. Now, x comma y comma k. See, uh, see, Lokesh, if you're thinking you have to remember this so that you can use later, you need not. If you can try to explore what you can do with sets, or if you can try to explore what all you can do, then you can find those things on your own. I haven't learned this technique of keeping them as adjacent segments somewhere, right? I have done it on my own sometime. Okay, maybe if I maintain adjacent segment, will that make my life easier? That was the question I thought. Okay, if I maintain adjacent segments, will that make my life easier? And then it would. So I just used it. So I will do it because I told I will. But I'm just trying to say you that let's just make them one based zero based index. So L equals to Y now. R equals to, we want to store QX and QY, QK. Because we want to know what was X and what was K, right? To answer what would be the element. Yeah. L equals to Y, R equals to Y plus K. Let's just keep R as the next element. Instead of this, I'll just keep R as this one. Do not even worry about R plus 1. I don't even want to do R plus 1. So now auto f equals to s dot lower bound of L comma 0. So we want anything that's beginning from L, that starts from L. And then we keep removing this shit and we remember what was its value. See, there will exist at least one thing, or it may not. What I mean is, let's say this is our L, this is our R. So this thing will be automatically cut. But it can be like this. Then there existed something like this, right? So there definitely exists a lost element, but it can be like this too. Like this, instead of this, it could have ended perfectly here. Then the next thing starts at R. So we will try to maintain these values. We will try to maintain these values, but when next thing starts at R, we don't add this thing. So it's fine. See, when it is like this, we add the remaining thing. We only try to keep track of this value and then we add the remaining thing. Right? We remove all the things that are starting after L and before R, and once we remove all, we will keep the track of these things. And okay, it may never exist. It may never exist. In this case, it may never exist. Even in this case it may not exist, like nothing exists that starts after this and intersects. But then minus 1 is fine then, because this thing perfectly starts at R, so we don't add anything. I'm just trying to say something small. Did you get like what I was trying to say? I was just trying to check if our corner cases will work or not. Say yes if you understood or not. Doesn't matter. So we have auto f. I'm just trying to keep find its value for whatever, while I was just trying to see, we have to remove things, right? See, I will remove whatever starts after L. I'll remove those segments and before R, and then I will try to keep what was their value, because if their value was if their value was 5, after adding this I have to add, make it like this, right? I have to know this value now. So I'm trying to keep the track of that value, but this value will not exist if this was the case, because there is nothing after L and before R. Then minus 1 will work because we won't add anything in this case. We won't insert anything like 5 because it perfectly starts from, because there was this condition. So I'm just trying to just say, what if it doesn't exist? Like, what if that value doesn't exist? Then it will work out, is what I'm trying to say. Is that fine? I hope it is a bit, at least a bit. See, I don't know if I can directly remove them. So I will just write like this. See, this is the value 5. We hope it will be 5. Now I will erase them. After erasing all of them, I just have to see. Let's also add our thing, which is this I comes from this I. Okay, we're trying to say L, from L there is I touching. From L I is touching people, and if touching continues after X or after R, we have to keep who has touched them previously. Otherwise, that will be lost. We are adding. This is not val. This thing is this thing which starts from later. That will already exist, so it is fine. So just adding this is fine. And now here, when we are here, I also want to store these things, which are qx of I equals to here. I have to sleep too. So, who touched this is what we want. We have a set that says who touched whom. So, what we have to do? We have to find the segment. Let's find something that comes after this and then do x minus minus. Okay. After this, I'm just using upper bound to get something that is after this, and then I do f minus minus. Now we are at the segment that touches this, and dt touched it last time, but just leave that. Hmm. Just join. You can repeat. I have explained how to not use segmentary because I hate it. I hate how people say they want to learn segmentary or they have learned segmentary. So instead of doing range update by segmentary, I'm doing range update using sets. So range updates can be done using sets. I don't know that, but just now I found it and then I'm just doing it. So we are maintaining ranges as as array as some set of ranges, and when a new thing will get added, we remove few things. Yeah, I hope it works out. So now, mm, idx works. See, second will have our value. Is that fine, Lokesh? You can like the video because it's good video. You can skip parts, and then when I try new question, maybe you can watch it from there. Yeah, thanks for it. Mm, Now, if idx is the one that touched it, then the value of, if idx equals to 0, then return b of 0, else return a of, we also want this thing, we also want qy of m plus 1, qy of I equals to y. So idx x is at y now. Instead of this, is there a better thing here? Pause seems better. So we want this position. What is there in this position? But what would have been there in that position is pos minus y, which is qy, plus qx of idx. We don't need k. We don't want to know what the k was. We just want to know what's the offset we have to go back in here. So my thinking of maintaining 2 is enough was correct, but what 2 was wrong? Just this will work. So should we try to run it, Lokesh? Ah, got it. I saw the number increased from 7 to 8. You liked it. Should we try to run it, Lokesh, or no? It will probably give some error because we are using sets and shit, right? Hmm. How to debug this shit now? It won't be too difficult. 1 minute, give me some time. I just put them in here. Will this not work? I'm debugging it. I it won't happen, I think, because I'm trying to find upper bound and then I'm coming back. I thought about that because we have 0 to something, 1 to something, 2 to something, up to 1. Even at n we have something. So from pause, upper bound, it will go to something. There is definitely something on pause. And then we came back to see what is on pause, on pause, position, pause. So that, sorry, that will definitely exist. So let's just see after one or two operations, one operation. What is this? If IDX is 0, what we have to output is B of pause. We don't make such mistakes, I think. So now it is 0. So let's try to remove this return to. I mean, if I have written a code, it should be, it is likely right. Now, bro, now I can solve it. I can solve it before I sleep. You think I cannot solve this at all? Uh, Mm, so now again, let's return and then just see static in f equals to 0. If f plus plus, if f greater than 1, return 0. So see what's happening. Initially we have 0, 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, 0, and then we have 2, 2 comma 5, not 2 comma 5. Yeah, we have this thing, 1 3 3 3, which means x is 3, y is 3, z is 3, k is 3, 3 4 5 is this length mean 3 4 5. So after you add that from zero based index, I think it's 0 2 3 4. So 2 3 4 will have 2. Worked very well, right? This was correct. So this was the I equals to 2 is this thing. And once 3 comma 3 means, I will tell for the new people what 3 comma 3 comma 3 means. 3 comma 3 comma 3 means these strings got copy pasted onto this thing, which means in zero based index from 2 we got an array, we got these three things getting updated. So initially everything is 0, and then when 2 to 2 3 4 got updated to 3, our set will become this. First element indicates the starting position, second element indicates its value 0 comma 1 comma 2 to here it's this, and then it's right. Let's see after two things if it will give a fault. Let's just increase this inside of this so that we only see after updates. So after adding the second segment, it got error. When we are adding this thing, which is 214, which y starts from 1 and length is 4. So when I'm trying to add from 0 to 1 to and then remove this partially, it got an error. 1 minute, guys. In this case, this should have been empty. In this case, this should have been empty. So I mean, we could have used it segment tree. I know that, but this also will work. What happened? Wait. Okay, it got returned. It won't print values so far. So then let's just debug directly. Okay, it is empty till here, and then we don't erase anything. And then, okay, yeah, this is the mistake. I am trying to use this F. I'm trying to use this F, which will be here. Then I should not update the previous array. If I update, this F will become meaningless. That's why I have put all these things into a temp and then I have erased them because I don't want to delete the F pointer when it is in the set. So now remove few things. This will definitely exist. And then we are inserting if something has to be inserted and then we are inserting this back. So this will work out surely. I am pretty sure this will work out. I can remove all of this. Mhm. Wait a minute, guys. Ooh. Oh, after arrays also it may not work. After arrays also it may not work. So we have those things. We have added one more stupid thing into that. Val will make sure it's unique because yeah, it will make sure it's unique. Not it will not make sure it's unique. This must be added. So it was not there present. If it was there present, we won't be removing it like that, adding it like that. So this would work. Fuck. Do we have viewers or everyone left? Lokesh, are you there? Yeah, if you keep that static, it will just increase it seems. It won't become zero. I don't think F will become pointed to zero. I think, and I don't think F will become here. F will not become get pointed to zero. Here, there F will not get pointed to zero. 1 minute. This star F will exist because there is n. I have added this n right. So in the worst case too, 1 minute. I'll just find that error. In the worst case too, this will exist. Oh. Wait, yeah. What was there? The next thing, if that is greater than or, there is the part left here. I'll just add one. Just check maybe. I mean, this should not be happening. Let's just add that. We can just do this any number of times. Damn. Here it should be fine. Any of you know how to use the debugger? I never knew how to use the debugger. Wait, this should work. If z equals to 1, oh, okay, it was happening at second iteration. That's why it's coming like this. We have to go down again. Hmm? I think it was happening at second iteration. That's why it happened like that. I can do this thing now. So this was our array. That is fine. And we have, wait, f equals to empty should have been printed. Here f equals to empty should have been printed. So in the second one, x, y, 4, 1 will be 0. Okay. 0 comma 0 will be removed, 1 comma 1 will be removed, 2 comma 2 will also be removed. So it won't be 0, it will be 3, because that many things must be removed. 3. Huh? Yeah, my charging is also is not there. I had to on the switch. So that was 3. And then where are we getting error? Is it here? So now we have added 4 comma 2, because this will go, this will remove these three things, and then it will add 0 comma I. So that from 2 to 5, before it was the 2 to 5, now it will start from 4, because till 4 the new thing will come. So it's all about removing these three things now. Just removing those three things now. So it cannot be giving error after this. I think it won't give error after this. Oh, it's not giving error after this. So it's probably giving error here. Sorry. Ah, I mean, we are almost done. We can do this. This should be B, because this thing is guaranteed to exist in B and not in A. This is B. Fuck, nothing will work. One minute. It's almost done. This is not good way of debugging, but so is this the error all the time? Guys, we are almost done. So at z equals to 3, we are getting error, right? At z equals to 3, which is nothing but after this z equals to 1, after this z equals to 2, after this z equals to 3. So here we are getting an error. This is not even 1. This is not even 1. Just keep it here. We're almost done. We'll just find this one small error. Wait, 1 is fine, 2 is fine, 3 is fine, 4 is fine. Z equals to 6 is giving error. So this is only giving error. 1, 2, 1, 4. Should I use online GDP as someone told? For all that? Fuck. It's being too much. Let's use 17. Answer minus 2, 3, 3 are probably correct. Minus 2, 3, 3. They're probably correct. Let's ignore that. Wait, why are they wrong? First answer itself. Let's try to just see that one too. First answer should be 0. I answer minus 2. IDX is 2. No, this should be A only, yeah. It is guaranteed that it exists in A, not in B, sorry. 0, 2, 2, 0. Wait, it's going further. Zero. Oh, this should be the answer. 0, 3, minus 1, 3. Yeah, 0, 3, minus 1, 3. Yeah, that's going correct. So just remove this thing and then again do it. It went all the way. Is the last one 0? Wait, it went all the way. So what was the mistake then? Answer is 0, 3, minus 1, 3, 3. After 3, we should get 2. I mean, we can debug this thing for sure because now we know what's going wrong. What's the first thing that went wrong? After 3, we should be having. I probably changed something. Let's just see this thing. So it became 0, comma 6, 4, comma 2, 5, comma 0. This is our set. Is this correct? Because in 1, 2, 3, 4, 5, 6, we got 1 to 4. From 1, 4 things got updated, which is correct. Because from 1, 4 things, till 4 it got updated. And from 4 to 5, it's 2. So this is correct. Even this is correct. Let's just try to test this thing. After z equals to 9, here from 2, one thing got updated, which is second element is 1. From 2, one thing getting updated, it should make it, it should have added, it should have added 3 here. I think it's an implementation mistake. It's an implementation mistake. I should have been more careful before going to the solution. I should, because see, if we be careful, we don't make such mistakes at all. So what I have done was, the case I have missed was, the case I have missed was, see, if we have been careful, this would have never occurred at all. The case I have missed was, I just checked like if nothing exists, I just checked like if nothing exists, we won't add this thing so it will work out. But then here we should have added this thing. Here we should have added this thing, which is not equals to minus 1, we should have added there. If I don't add this, it will get added minus 1. This minus 1 will get added inside. Which minus 1? Yeah, this minus 1 will get added if I don't find that value. So after you find lower bound, initializing this, instead of minus 1, if you initialize that with this value, f is currently here, we should initialize with this value. If you initialize with that value, it's done. I checked that val cannot be minus 1 for a corner case. Of this corner case I checked, because in this case we don't add a new thing. There doesn't exist anything, we don't add a new thing, so I thought it's fine to keep val minus 1. But then in this case val doesn't exist and we have to add something. I thought this was the only case in which, because I thought if this thing crosses, I thought we'll find it, but now only these things crosses we will find it. So I thought I ruled out this possibility here. But then this can occur. So when this occurs, what we have to do is, so if star f dot, this is the only thing wrong because everything else is very clear, nothing else can be wrong here. If that is already crossing the next thing, so if it is like this and we are already here, I'll just do minus minus. Now I'll just do auto g equals to f g minus minus, and then val will be star g dot second. I mean, this was the only corner case. Other than that, it's not that complex. We are removing few things. This was the only corner case. How could this have? I mean, I tried verifying that here, like what we have to do in some corner case, but then this should be added. This value should be added. Guys, leave me. That's better because even I don't want to try this further. So now let's see. From 0619 was correct. And then 26 was correct, 42 was correct, 50 was correct. So this was right. So this is right. Because from one, only one element should get updated, and that should get updated with 9. See, this is going wrong. Something special. Only this is going wrong. Set is being correct. Only this is going wrong, and that we can find very easily. IDX was 0. How can IDX be 0? Ah, in that case, we don't print it. We're almost done. Fuck. 3 hours. 0, 3 minus 1, 3. Z equals to 6. This should have been 2. For that should have been 2. What was that? This one. 2 comma 1. 1 has been touched, right? Okay, I got it. I should set the initial values to -1 or 0. No. This is the last 10. Okay, upper bound of this may not work so properly. Upper bound of this may just give that. I just use upper bound of. But I don't think that is the error here. Upper bound of. Or I can use pos plus 1 too. Was that there? Seems that was the only error. I mean, it's an easy problem, but still, I haven't used unnecessarily some segmentary and debugging. Time limit exceeded, so just that should be fine. Time limit exceeded should be fine. Or using fast input, fast output, everything, right? See, time limit exceeded should not have happened because it's just login operations. Did they keep stricter? What was this test? This seems to be some technical issue. It's not like solution issue, but it's. I don't think anything can be improved here. See, complexity wise, this is very enough. 10 power 5 times login should work well. Of 10 power times login. There is some other issue. I'll just find it later. I think now it's not the time to find it. Right. So if you guys want accepted, I'll just copy paste something. 1 minute, guys. We are about to do this. Is it adding S or setting S? Adding S. I want it to set S.